Next, we have Sammy Cheung, who's the CEO of Efinix. Sammy is an entrepreneurial and innovator who started out wanting to combine disruptive technology and innovative ideas. And so Sammy co-founded Efinix back in 2012, and it's become a very disruptive entrant into the FPGA market. Now, as many of you know, supply chain issues have been pretty much on everyone's minds. But I want everyone to think for a moment about how hard it is to build an ASIC these days versus sourcing from an FPGA. FPGAs differentiate because even though you can make it custom hardware for your solution, on an FPGA line, they don't have quite the same supply chain issues as you would if you were making a custom ASIC. So it's really been very interesting to watch Efinix's growth during this very difficult time. Prior to Efinix, Sammy led the IC group at Stretch Inc., where he enabled their video surveillance business. So he has a background in some of these aspects that we are going to touch on today. He steered teams that worked on the leading edge Stratix and Cyclone FPGAs at that other company that was acquired by Intel that I won't mention, and was instrumental in transitioning hard copy structured ASICs from a technical concept to reality, generating more than $100 million plus dollars per year in sales. Sammy started his career in Cypress Semiconductors, so he's a veteran of the Valley as well as of Asia. And after receiving his master's in engineering from Cornell University, where my son is going, he also received an MBA from UC Berkeley in 1997. Sammy will be presenting on making deep learning more accessible to developers, and you can also go see Efinix's booth over at the exhibit hall. And I would tell you I'm really impressed with Titanium 180. They're already up and running TinyML, and seeing some pretty amazing benchmarks. But I don't want to steal his thunder. So without any more delay, I'd like to introduce Sammy Cheung.
Thank you. Forward.
All right. Good morning. As you can heard from David, that I'm a hardware guy, and you're wondering why I'm here. And we finally get some attention because of all the supply chain issue and people realize that hardware is hard. And today, I'm not talking about algorithms, you guys better than me. And the focus is really talk about efficiency and time to success. And why Efinix can help you in that area, especially when you have all the innovation, spending years of time. And finally, if you start talking about deploying products in the edge, you don't want to get stuck in the middle somewhere, right? So we want to share with you some of our ideas, what we developed, and we are transforming ourselves from general purpose devices to become one of the key enabler in the edge machine learning area. So what do we do? Simple. We build the most efficient FPGA. I will explain about that when we talk about the technology. Why is efficient? I think more important is we sell time to success. You heard a lot about time to market. It doesn't work because in the good old days, you pick up FPGA, pick up a GPU, great, easy to program, get to the market, but you figure out that you're not competitive. Reason is you know how power hungry they are deploying the edge, how big the size will be, and at the end, I mean, it's fine, we can go to ASIC. This is even harder if you want to do that. So you don't want to wait until that point to start struggling. You want to start thinking now, why going with Efinix? I will explain later. Of course, the way we do it, we are very efficient technology, not just size, area, power, performance, etc., but also very easy to deploy and build. And we'll build a lot more in the next 5 to 10 years to make sure that you have all the access to the platform. So just give a quick introduction before we jump into some of the examples how we deploy TinyML onto our platform. And first of all, we headquartered in Cupertino. We have global locations everywhere. Founded 10 years ago, this year's 10-year anniversary, 140 plus employees. We only start really blitzing into the product market about 5 years back when we start developing our first generation 40 nanometer Tri-on FPGA. And then in last 2 years, we also developed our new 16 nanometer titanium FPGA. All the trials in productions, and we have 2 members of the 16 nanometer already in production. So where we are now, so we're a small company, but over the last 3 years, we have sold over 10 million units. Also, we roll out over 30 plus product variations from Tri-on to titanium. And we just get to become profitable this quarter. And we check, we exceed 1% of market share. Small, but we show up in the pie chart. So we become relevant. And just a simple stuff is, this is probably a very difficult thing unheard of in the industry. The last 3 years, how we can ramp so fast, that must be a special recipe. You can see later on, because our technology is so efficient, and we don't have a big sales force, but customers just like it. And also, somewhat relevant as well, because of the technology using standard recipe, I'll touch it. We have no issue in the supply chain. Plus, and also we've seen the change that, as you can see, a lot of customers of us are actually camera customer, imaging customer, doing imaging applications. It's perfect time to take a technology which is small, efficient, and blending low power and high performance and scalability together. So quickly, couple minutes on our technology. I don't want to touch base too much. It's totally hardware here. Traditional FPGA, gate array, programmable gate array, you have logic and routing. And traditionally, 35 years ago, right, you're probably running a lot of FPGA around. It's a 35 years old concept. So they have logic and routing separate. So in order to route, to use the silicon efficiently, they have to build the largest switch as possible to scale the device and get the performance to build the largest logic block. We go totally different. We scrap the whole concept and talk about building an efficient fine-grained cell, which is small size and be able switchable between logic and routing. The effect is we get very small die area, very low power, low cost, easy to make, but still high performance. Our pure question, you got to be trading off. No, our performance is the same or even better as the top in the industry in titanium. And another thing, you cannot scale. You're probably building like this very small device for gadgets. No, we have 180K device coming up. Our next 375K is going to coming out Q1 next year. And we continue to roll out device that is scalable. And then last question for me, usually, it has to be hardened. No, it's 100% field reconfigurable. So this sounds like a dream product come true, right? Until we show it, show the product. So this is probably the most important slide that I show. Traditional FPGA, when it needs to get performance and density, it has to trade off cost, power, and size. Then why now you understand most of the leading FPGA vendor they have to go after the big infrastructure data center, because that's the only place that you can burn power, no problem, right? But you start getting to the edge and some of the mainstream application, it's just too expensive and too power hungry. What's the difference in Efinix? The trade-off, this trade-off, but not be the same. And we can scale with the density and performance without giving up cost, power, and size. So, and just a preview a little bit, when we move from 16 nanometer titanium to the next generation, the gap will be even more obvious. And then I mentioned about we have titanium TI 180, which you can see outside in the booth. And the most important, it's not about one thing that can stand out in the industry. You have to do all these things. This is just a snapshot of the key things. And of course, I mean, the technology itself bring it the best value. When you're small, of course, and you can push so many logic elements, so many DSP blocks, so many embedded memory and memory interface into a small form factor that you can use. It's the best value. And also, is when you build small, and then you can save a lot of cost in your edge system. Another thing is in FPGA world, it is hard to do blending low power and high performance together. And right now, you can start using the platform in Efinix that provide you all of the above, very similar to in general, that there's no reason to build general ASIC. Right? Another thing is we would talk about how we enable the TinyML on the RISC-V platform that is a soft SoC platform that implement on an FPGA. When we can make the FPGA so efficient, so small, basically you don't need to build a hardened MCU block or processor block. You can just deploy a standard open source RISC-V SoC on the fabric, running 300 megahertz, 350 megahertz. We probably can squeeze it even further. That probably cover about 70% of the general purpose applications. And on top of it, we put TinyML on it to start accelerate different layers to give the performance way better than the standard MCU. The last but not the least is standard process recipe. And a lot of our peers very surprised that over the last 2 years, we continue to get wafer surprise and so on. Part of it is the world has already changed long time ago, old FPGA, and they have been using special recipes, special metal stack, and we use standard recipes, still be able to have a disruptive specification compared to the old FPGA. So that enable us to continue, don't have the supply issues. Let's jump in. Why all these things is relevant? I want to set the tone. It's going into the sort of the AI deployment challenges. I would imagine it's very similar to any product deployment. And it's always things are changing, right? First of all, I mean, you have to think about your innovation, your product had to have a good system adaptability with the market changing. However, the whole point implementing in the edge side, especially on the edge, is power, cost, performance, and then also latency. I mean, standard simple processor no longer helpful when you start to become competitive. When you use expensive processor, that may not fit in your product requirement. So there's a lot of things in there to be considered. We talk about field reconfigurability has to be there. Things are keep changing. You cannot wait for the standard never set. And at the end, it's talk about time to success. It's not just you go to prototype, go to a big expensive device, go to market. You have to figure out a way to go all the way to volume production and profitability. In the ideal world, it's a straight road, nothing blocking. You probably have a lot of experience in the edge. I mean, it's very easy to get into GPU or a traditional FPGA. I have customers switching to us. Primary reason is they just cannot be competitive in power and cost, or some of the spec, especially in the camera, just cannot fit it in. So, and then when you choose MCU, it's when you try to upgrade in terms of performance, competitiveness, they cannot. So we see areas that various customer is easy when they go to the first market, but they really want to become super competitive and so on. It's become harder and harder. And one other thing is usually people didn't think about it much is they think the fourth path is easy. It was advertised pretty easily. You go to just build an ASIC and so on. You can get your performance. Don't worry about that when you get your custom build ASIC. That doesn't work. I mean, because ASIC is hard to build. And also, we just all experience that if you are just a singular ASIC chip, how likely you can secure supply down the road when you are very successful. So a lot of little details are downstream. And so it's kind of like this is a technological business model on the two right-hand side of the spectrum. It's kind of like has been around 30 years. But now, we don't believe they are really suitable for edge deployment in the next decades to come. So Efinix is not like a straight road, no roadblock. That's once in a while you have to stop to make sure you don't run over people. But some simple, straightforward, get you to market, get you to success. You can always go to a high volume productions and even just with the existing FPGA. So, so that's what we try to share with you. Today, we are already everywhere in the last 3 years because And keep in mind, we are not a big brand. We don't have all the resources. However, the product sold itself. I mean, we already into the CMOS sensor camera, LiDAR, and thermal camera, TOF, and we have also the other side, like display, printing, and everything, general purpose things. So essentially, FPGA is just a matter of time. We are going to be in all sort of application. The fact is how the developer take advantage of this to insert your innovation in this ecosystem, rather than picking something, reinvent it yourself. And that's the most important point, why you need to start thinking about choosing a FPGA platform for your future deployment. And one of the things that we developed over the last 2 years are Efinix TinyML. So we saw a lot of peers FPGA company have developed more a proprietary approach, how they approach AI machine learning. Instead, I think we took a slightly different approach because we know our advantage is we can run the RISC-V SoC very well on our soft fabric and very efficient, very economical. So we don't need to go and reinvent the wheel. So what we did is to be able to enable the TinyML platform and keep it as open source as much as possible to give everyone the freedom. And in case when you go to really high volume, want to really build a custom chip at the end, you still have the freedom, license free, and it's totally 100% field reconfigurable. And the AI framework we provide for acceleration is free. We are not going to charge you, and then you can use it. But if there's anything that we can help, like some of our customers, we'll give them a service to enable them. At the end, the more important is, especially when we move from a few years back, I look at some paper, how to deploy MCU on the edge machine learning. Now, I think it's the time to start thinking about more horsepower, more capability in the FPGA from Efinix. I'm not diving in too much. I think all of you understand. We basically deploy the platform with the standard TensorFlow, TensorLite, and get the TensorFlow Lite runtime file. And the key part is it can just run directly onto the our soft RISC-V SoC platform. However, the key is how to leverage the custom instruction nature of the RISC-V to accelerate different layers to give you that competitive edge, to give you that performance, to give you that customization, to give you that differentiation of your innovation. So on the right-hand side, you can see that it's basically, it's a standard RISC-V core that is, by the way, it's open source. That means anyone can take it and use it as the platform. And also, if I have some customer, they have their own RISC-V platform, they can plug it in easily. So we have no restriction. So we don't need to get stuck with us in the hardware side. And the key part is on the right-hand side is we building up an infrastructure, allow our customers to do the accelerations of different layers. And also is allow customer to be able to integrate customized functions to enhance the performance and differentiation. So this is just diving a little bit more, an example about the media pipe phase mesh. And it's just implementation. What we did is to go through the same flow we discussed, and then looking at, and we have a profiler provided to allow you to identify which layer can be accelerated. And as a matter of fact, we do provide just the tiny, we will accelerate the key layer already, provide as free as an accelerate layer for the customers. And as you can see that going from the beginning to the end, we can shave over 80% in terms of the latency for the key layers. And also it depends on the product that you deploy. I mean, if you can afford a little bit bigger device, you can go even further in terms of performance when you use bigger device because there are more resources in terms of embedded memory and embedded DSP block that can do much better accelerations at the end. We have started for a little bit while to start putting up some benchmark. It's not everything there yet, our bigger device yet coming. So we'll have more benchmark about TI 180 coming up. But we do see the first shot. I mean, we expect that compared to MCU, we get the MCU class of inference energy, power level. At the same time, we can get that much better performance. Cost structure is the same. And the best part is you don't need to get stuck with a proprietary sort of flow from some of the more standard old business model. I mean, it's a standard open source TensorFlow-like microsoftware level. So we make it easy for everyone, and we provide that freedom for you to innovate. But some customer that's interested in just use our standard platform to deploy. So we are very flexible in that fashion. So there are a couple of case studies and some customer cases I want to share. I mean, the first one is, I think most of you heard about the transformer and the convoluted layer things. And basically, is after a while, the world is changing. I mean, the innovation can be limited by a fixed hardware availability. So when folks start switching to transformer, all the existing hardware may not be good enough to do that. So as you can see, one of our customer doing right now, they're doing full transformer deployment, and the convoluted layer is only like 1% of the latency, and they have to have hardware that allow them to be competitive for fully connected and soft mats. So, and it is perfectly no problem with Efinix FPGA. Of course, nature of the FPGA can take care of that. With Efinix, it provides that kind of efficiency that they can go to market, win, and can change as well. So this is just one of the examples. We don't know a couple of years later, will there be any more changes? But once again, machine learning cannot go with specified hardware, specialized hardware. Another thing is the changes of YOLO over time. It's also pointing to the need to go into the type of platform with efficient FPGA. I'm not going to dive in too much. I think the virtual session will talk a little bit more. I want to jump quicker. We have existing customer cases that the first one is smart home. We are replacing a MCU implementation. The customer really want to have a lot more lower power. We get more performance for them, and they get actually similar cost structure when they do the deployment. The second one is about instant segmentation. I think this one is, let me think about this one. This one is really a GPU use case, but they really want to go smaller size, and they go with us. So GPU, if you start talking about power size is important, GPU cannot compete with us. We can do the same thing efficiently in the central case. And the last one is, that's the transformer implementation. It's an outdoor smart robot. And then we are doing quite well with that. I mean, there's no issue because it's a flexible, reconfigurable hardware. So, talk about framework and future. I mean, I believe that's in the virtual sessions, a lot of discussion. But the next step we are going to do is deploying TVM for our bigger devices. And not only you can use a single chip of us, we can work as a very efficient machine learning accelerator on the side of the central processor. So that's the roadmap we have. It probably will be more going into 2023 when we start rolling out the bigger devices. This is what we have. FPGA hasn't changed at all. We have to cover all markets. The difference is we build the device very efficiently, very small, very low power, and high performance and scalable. And today we have 30 plus variations. We expect the next 5-10 years, in order to cover the usage, we want to build at least another 10x or even 20x of the variations, because we can build it much faster and easier than other older technology. So we have a booth outside there, and then we have a lot of information on our website. So please feel free, have questions, and also come to take a test drive and how to run TinyML on our Titanium. Thank you.
Folks have questions, please come to the microphone. Okay, firstly, I want to say thank you for plugging the virtual conference. You mentioned there that there's also a presentation coming on.
Yeah.
Additionally, from Mark Oliver from Efinix will be there to provide additional insights that you didn't get today. So really pleased to have the CEO here, but we got the guy who actually makes things happen also in the audience. Okay, I have a question. So, and this is kind of confrontational, but what differentiates you from other FPGA makers? What do you think the key 3 things that differentiate you?
That's the curve I showed. I think the key things is we make it so efficient in a way that, I mean, anything else in the edge got to be small, low power. But we can make it scalable in logic density and also high performance. That's unheard of. No one did that before. And FPGA is supposed to be one of the better devices, and our peers, they are all, the main peers, one of them is my investor too. So they focus on, the technology only let them to do the data center, the high-end stuff. And no question, they have the most sophisticated software cockpit to run things. But when we start talking about general purpose, mainstream deployment of machine learning, they need us to be able to go out there and make it available. And also, silicon availability is another thing that adding up as well. So,
yeah, I tried to touch on this earlier. I think this is one of the real eye-openers from this, supply chain crisis. Is that if you want to build an ASIC, unless your logo is a fruit,
no,
you're not going to get any wafers.
You got it. Yeah.
That's basically the recipe. But if you're an FPGA vendor, you can still make custom silicon.
You can. That's only basically that custom ASIC was an insurance policy that doesn't work with other devices.
Yeah.
And with us, you have a long roadmap. You can wait until you're really truly successful. Yeah. But the best part is we're still running the same run card, and then the fab will like it. So that's why we got the supplies. So.
Yeah, as an old hardware guy, $2-3 million wafer starts were decades ago. Now it's can't even get in the door. But one of the other interesting things that I heard you touch on was the integration of DRAM and the controller, which is pretty rare still, even today, for FPGAs.
Yeah, absolutely. I think be able to mix it together with the most advanced low power DRAM interface is the key. And TI-180, we're rolling out a 2.6 gigahertz LPDDR4, and that's actually perfect for edge implementation. Allow as much as possible to swap in terms of the image and through the memory interface. And on top of it, on the die, they also have a lot of embedded memory. So it gives you the best mix and match in terms of how to deploy your integration of machine learning and also a lot of low latency data functions.
Yeah. So. Tomorrow we have a panel on, not that I'm plugging it, on new memory, new materials and technologies for AI. One of those aspects is actually memory and the memory interface and memory and compute. And from the data that we have, more than 500 times the size of energy is spent just in the memory interface and DRAM versus the actual FMAC, the compute. Mm-hmm. So that's a really important thing. Now, one thing I know that you didn't touch on is branding. So I heard a rumor that you guys do custom ASICs without the Efinix brand on it. That's pretty bold.
Yeah, I think we call it a platform. There are two sides of the coin. Our technology is so portable, so easy, and we always leave it as the rising star option for our customers. I mean, if let's say they go in, we have customer going buying like 1,000 units to like 20 million units. But if you start skyrocketing, say that I have a 50 million units, I really want to go to ASIC, it's pretty easy to go through us. We can do that chip for you.
No one would know it wasn't.
No, I mean, yeah, we have different, no one would know. But also, we do have publicly you will hear from us more. I mean, we do have a platform business that it's not individually, but we're working with much more like a bigger company, a bigger region to do things that can help to proliferate our devices. As you heard about, we plan to increase our variations. I mean, by the time we roll out all the titanium with 50 plus, we probably want to increase to 10x. Once we build up the bigger matrix, all of you can enjoy I mean, there's no reason to build custom chip for like 80% of the chance, right?
And try to wrestle with the supply chain issues
Yeah.
without a Apple-sized, fruit company-sized staff to manage it. Yeah.
Sure, sure. That's a key part why standard recipe in a disruptive technology is important. We actually reverse the old day of fabless semi is not quite there, because right now we are more helping the big foundry to sell their wafers in a glorified way. And if we do well in general purpose, we probably can help them to optimize the profit, maybe 10-20% of the capacity. I mean, we have to look at this way.
So it's a win-win.
Yeah, so that's why if you're counting on a 30-year-old technology or business model, that probably won't work for edge machine learning and AI deployment.
Yeah, and again, I just want to emphasize, 8-9 years ago at NVIDIA, I was struggling getting FPGA makers to put memory on the package, and you guys did it.
Yes,
it's available commercially.
we did it. We have another line of what we call system in package that will integrate memory, flash, and all the necessary ingredient. I don't want to lead too much in there. I mean, you can do a lot of things in SIP as another line card, right?
So what Sammy is politely saying is, come see us in the booth. Okay, that's it. All right, thank you very much.
Thank you. Yeah, David.